We've all seen it, right? You ask an AI a question and it gives you an answer that's incredibly detailed, super confident, and just completely wrong. Well, that's called an AI hallucination, and honestly, it's the biggest paradox we're facing with this tech. Is it a dangerous bug that we need to eliminate, or is it actually an accidental feature, something that unlocks a whole new level of creativity? Today, we're going to dig into that exact question.
All right, here's how we're going to break it all down. We'll start with what this confident lie looks like in the real world. Then we'll pop the hood and see why the system is technically flawed. After that, and this is where it gets interesting, we'll explore how that flaw might actually be a feature. We'll look at how we can manage it, and finally, what all of this means for our future working alongside AI.
First things first, let's really get our heads around what we're talking about here. This isn't just your garden variety computer error. No, this is about a machine that can lie to you with the poise and confidence of a seasoned expert.
In this case right here, this is the poster child for what can go wrong. Back in 2023, a lawyer used ChatGPT for legal research, but the AI didn't just get a few details wrong, it literally invented 6 entire legal cases out of thin air, complete with these bogus citations that look totally legit. It was a huge deal, and it perfectly captures the danger we're talking about.
So, let's nail down a definition. An AI hallucination is a confident, plausible fabrication. And here's the key. The real danger isn't that it's just wrong. We can spot wrong. The danger is that the lie is so believable, so well-structured, that it can fool people who should know better.
And this isn't just a one-off problem in the legal world. It's happening everywhere. In medicine, AIs have confidently given out lethally bad advice, like suggesting someone replace table salt with a known toxin. They've even invented explanations for medical conditions that don't exist. And with images, wow, the models can fail at basic logic. You ask for a pitch-black unicorn in an all-white jungle, and instead of understanding the concept, it just smears black paint all over the image. It shows there's no real understanding there.
So how on earth does this even happen? I mean, how does a sophisticated piece of tech break down so spectacularly? To get it, we really need to look at the guts of the system.
It all starts with this one big kind of flawed idea called the closed world assumption. See, the AI is trained on a gigantic but ultimately limited set of data, and it basically assumes that this data is the entire universe of knowledge. So when you ask it something that's outside of what it was trained on, it has no programming to just say, you know what, I don't know.
And what's really fascinating is that this breakdown happens in a predictable 4-step chain reaction. First, you give it a prompt that's out of distribution, something it's never seen. Then, step 2, the system's architecture just fails. It doesn't have a way to say, I don't know. So it moves to step 3. It defaults to what it can do, which is remember and repeat patterns. And that leads to the final step. It just starts stitching those remembered patterns together into something that looks and sounds plausible, but is totally, completely fake.
Okay, so case closed, right? It seems pretty obvious. This is a bug, a really bad one that engineers need to fix and fast. But what if that's only half the story? What if this exact same flaw is also the source of the AI's greatest strengths?
And this is where things get really wild. We're going to look at the other side of the coin, the argument that this bug is actually a feature, a kind of accidental, chaotic genius.
Just look at this. It's the whole paradox in one slide. The exact same mechanism, that tendency to just make stuff up, is an absolute disaster in law and medicine. But you apply that same process to science, and it starts generating novel molecular structures for new drugs that scientists had never thought of. You apply it to art, and it creates these bizarre, mesmerizing images. It's the same process, but with totally different outcomes.
You could almost call it a symbiotic flaw. See, we humans have our own bug called design fixation. It's when we get stuck in a creative rut, just recycling the same old ideas. Well, the AI's flaw, its ability to generate weird, random, unexpected connections, is the perfect cure for our flaw. It helps break us out of our own mental boxes.
And Geoffrey Hinton, one of the godfathers of modern AI, he takes it even further. He argues that this pattern matching, kind of making it up process isn't just a cheap computer trick. He thinks it's actually a lot closer to how we think. We're analogy machines that run on intuition and resonance, not cold, hard logic. And in that sense, these AIs are mirroring a very human way of thinking.
So if we can't get rid of hallucinations, and maybe we don't even want to get rid of them completely, the new question becomes, how do we manage this? How do we control the mirage?
Well, the best technical defense we have right now is something called Retrieval-Augmented Generation, or RAG. Think of it like this. A standard AI is like a student taking a test from memory. A RAG system is like giving that student an open book test. Before it answers, it's forced to look up the facts in an external, trusted database. It grounds the AI in reality before it's allowed to speak.
But, as you can see here, there's no silver bullet. Every single solution involves a trade-off. RAG is fantastic for getting facts right, but it crushes creativity. Fine-tuning a model on better data is super expensive. And a lot of the time, the burden just falls back on us, the users, to get better at prompting.
And this leads us to a really crucial point. We are in an asymmetric race. Generating plausible figs is computationally easy, it's fast, and it's cheap. But verifying facts, that's slow and it's expensive. It means, for the foreseeable future, making up believable nonsense will always be easier than proving it's nonsense.
So where does this all leave us? What does our future actually look like working with these incredibly powerful, yet fundamentally flawed tools?
It all comes down to a fundamental shift in our mindset. Remember that lawyer? He treated the AI like an oracle, a perfect, all-knowing source of truth. And he paid the price. The future isn't the oracle model. It's the co-pilot model. The AI is your brilliant, creative, but sometimes unreliable partner. It can draft things, it can brainstorm ideas, but the human, that's you, has to stay in the pilot seat, responsible for checking the facts and making the final call.
And maybe the deepest change this technology forces on us is that we have to split the idea of accuracy from the idea of truth. For an AI, accuracy is just a game of statistics. What's the most likely word to come next? But for us, truth is so much more. It's about context, it's about ethics, it's about verifying things in the real world. They are not the same thing.
This quote from the United Nations University just nails it. Never assume that because an AI's information is accurate in a statistical sense, that it also equals the truth. Those fake legal cases were statistically plausible, but they weren't true. Truth is and will remain a human job.
So we end up right back where we started, with this beautiful paradox. If an AI's biggest weakness is also its most powerful strength, then maybe we need to rethink what intelligence even is. Maybe the goal isn't to build a flawless, perfect machine. Maybe it's to learn how to collaborate with a totally new kind of intelligence, one whose very imperfections might be the key to unlocking our own next great idea.